Look at the most complex systems operating in our world right now, from the navigation of probes in deep space to the training of artificial intelligence. Underneath the hardware, they all run on a single invisible language. For centuries, mathematics lacked this kind of universal code. It was a fragmented collection of clunky methods, relying on memorized procedures and isolated examples that only worked for specific scenarios. This shifted in the early 9th century, when Muhammad ibn Musa al-Khwarizmi began his work in the heart of the Abbasid Empire. Al-Khwarizmi wrote his text as a practical handbook for civic duties, such as accurately surveying irregular plots of land and fairly dividing inheritance among families. He published his work as Kitab al-Jabr wa al-Muqabala. Instead of offering distinct tricks for every situation, his text introduced a reliable, systematic approach for finding unknown variables in any context. By solving these local, practical problems, Al-Khwarizmi initiated a relay race of knowledge that would carry his methods across continents and centuries. Copies of his book moved swiftly along the trade networks of the Islamic Golden Age. The era's sharpest scholars recognized that this new method offered immense computational power and adopted it almost immediately. The text took root in Eastern intellectual hubs like Samarkand, where it became a core part of the curriculum in major educational institutions. Mathematicians in cities like Bukhara pushed the concepts further, introducing rigorous geometric proofs and expanding the system into higher levels of mathematical reasoning. Simultaneously, the knowledge flowed westward, reaching audiences in major Mediterranean centers like Damascus and Cairo. In these cities, algebra matured into a robust mathematical discipline that architects, astronomers, and engineers used to scale up commerce and construction. During the Islamic Golden Age, this set of rules for property division evolved into a central pillar supporting wide-ranging scientific inquiry across the empire. A critical turn occurred in the 12th century, when the Islamic world served as an active intellectual bridge connecting the East to Europe. Translation centers in strategic gateway cities like Palermo worked to funnel centuries of Arabic scholarship directly to European readers. In 1145, English scholar Robert of Chester translated Al-Khwarizmi's text into Latin while working in Spain. He retained the Arabic word algeb in the title, which permanently entered the English lexicon as algebra. This era also saw the arrival of the Hindu-Arabic numeral system. It introduced the concept of zero and a decimal place value system, providing an alternative to the clunky Roman numerals used throughout Europe. Scholars like Fibonacci championed these new numerals, demonstrating to merchants and academics that they were more efficient for fast, accurate calculation. The combination of systematic algebraic equations and a streamlined numeral system provided European computation with a level of speed and accuracy that was previously impossible. During the Renaissance, mathematicians replaced long-written paragraphs with abstract symbolic notation. This abstraction allowed for a massive leap in complexity. Scientists condensed multi-layered logic into concise symbols, tracking variables through deep cascading calculations. This system provided the engine for the scientific revolution. It gave researchers like Kepler the mathematical framework needed to calculate and map planetary orbits. René Descartes furthered this by uniting algebra with geometry, creating the analytic geometry that Isaac Newton would later employ to formulate the laws of physics. By providing a systematic way to handle multiple variables, algebra became the essential bridge between theoretical laws and physical observations. Today, our world's most advanced technological frontiers, like machine learning, complex digital cryptography, and global high finance, they run entirely on these algebraic relationships. Every single algorithm driving these modern systems traces a direct, unbroken lineage all the way back to Al-Khwarizmi's 9th century manuscript. The spread of algebra was the spread of a new, systematic way of thinking, a method that moved effortlessly across empires, religions, and cultural divides. Al-Khwarizmi provided a universal method for solving the unknown, creating a language that remains our primary tool for translating human ideas into technological reality.